Welcome back to the second video on solving quadratic equations. We're going to talk about those non-real numbers today. So to begin, I just wanted to let you know that all of the numbers that exist in the world are called complex numbers. And you probably haven't heard this term yet, this term complex. That really just means that we're talking about the numbers that we know about and these new numbers that we're just learning about. So let's come over here to the left and we're going to fill this in. The numbers that we know are called real numbers. And some examples of real numbers: 5, -11, 1/3, √8, 0.587, right? All of these numbers that any number you could really think of, that's going to be a real number. The new numbers are called non-real numbers. And that's going to be things that have the square roots of negative numbers. So the square root, -1, non-real number. The square root of -8, that's a non-real number. We can even take real numbers and non-real numbers and add them together. It's still going to be a non-real number. So things like 2 plus the square root of -1. Okay, so anything that has a square root of a negative, that's going to fall into this new category called non-real. So why do we have to know about these new numbers? Because we're solving quadratic equations, and sometimes their solutions are non-real. So let's fill in these sentences. We have some very important information that we're going to have to know. Remember last video? We solved lots of quadratic equations. Every single quadratic equation that we solved or that we will solve will have 2 solutions. Okay, they will always have 2. We're going to learn a new word right now. The blank determines the types of solutions for each quadratic equation. Do you remember last video when we had the square root of the negative number? That's when we had those non-real solutions. That thing came from inside the square root of the quadratic formula. It has a name. It's called the discriminant. The discriminant literally discriminates against certain numbers. Okay? The formula for the discriminant is b squared minus 4ac. It's the stuff inside of the square root in the quadratic formula. It doesn't include the square root, it's the stuff inside of the square root. So that discriminant is going to tell us a lot of information. So if we could just focus on that, we actually will know a lot of information. So here are 3 examples. I would like us to start by finding the discriminant for each one. So let's start over here. The discriminant. Remember that the discriminant is b squared minus 4ac. That means I have to know what a, b, and c are. Well, here we go. We have a is 1, b is -5, and c is -9. Let's plug in and see what happens. I'm going to put parentheses around that -5 so that entire thing gets squared. -4 times a is 1, and -9 goes in for the c. Now we'll clean that up. -5 squared is +25 minus 4 times 1 times -9. That gets us -36. But when we have subtraction of a negative, well, that just became an addition problem. So now we really have a 25 plus 36, which is 61. So for this problem, the discriminant was 61. Look what happens if we graph that. I'm going to clear out everything in my calculator. If I graph in y1 x squared minus 5x minus 9, remember this graph from last time? It looked like this. I'm going to make a sketch of that. It had these 2 zeros right here. Ooh, I forgot to mention something. Let's go back into our notes for a moment. I wrote down that the formula was b squared minus 4ac, but I forgot to remind you that this means that the equation has to be in standard form, and it has to be equal to 0. Okay, I'm talking about the equation. Right? And that was fine. This one was in standard form, equal to 0. So when we get those discriminants that are positive, we happen to get real answers. So we got 2 real solutions. Remember that the discriminant, the 61, is the thing inside the square root. It's a positive number, right? So when the discriminant is positive, we get 2 real solutions. Let's try the next one. A is 1, B is negative 6, and C is 9. What's our discriminant here? I'll just write D-I-S-C. Let's plug into our formula. B gets squared, and then we subtract 4 times A times C. I just plugged into that discriminant formula. And now I'll simplify. Negative 6 all squared is positive 36. Minus 4 times 1 times 9, that's also 36. So this time we got a discriminant of 0. Let's look at what happens when we graph that one. Let's type that in. X squared minus 6x plus 9. Ooh, we have a parabola, and its vertex is on the axis, the x-axis. It only had one x-intercept. Remember how I said it's important to know that these will always have 2 solutions? It still has 2 real solutions, except we can only see that there's one x value. What that means is that we have 2 real solutions that are equal to each other. They're the same answer. And we're going to see more of what happens with that in class. So when the discriminant is 0, we're going to expect that the answers are actually the same answer. They're 2 of the same answers. And for our last example over here, let's try it again. A is 1, B is negative 3, and C is 7. And our discriminant is B squared, so negative 3 squared, minus 4 times A is 1 and C is 7. So this simplifies to 9 minus 28. And 9 minus 28 is negative 19. Remember we got that? This is actually from one of the questions in last video. We had the square root of a negative 19. What happens if we graph that one? We'll plug that into y equals. Look at that. Here's that parabola, and it doesn't have any zeros. So it looks something like this. I'll make a little note here, no zeros. In other words, no x-intercepts. And notice that the discriminant was negative. When we have a negative discriminant, we get two non-real solutions. We still get answers, they just happen to be those non-real answers because we have a negative inside that square root. All right, just another reminder here. Remember that we talked about different methods of solving and that graphing was a possible method? We wrote a little note down saying that you couldn't solve by graphing if it had non-real solutions, and here's exactly why. The graph doesn't have any x-intercepts, so we can't see the non-real answers on a graph. All right, everybody, it's time to try that survey. Good luck.